welcome to Eureka Math. This is Module 2 and we're on Lesson 3. Our objective today is to write and interpret, which means to understand, numerical expressions, okay? So expressions could be anything like this, right? That we call an expression. I'm not calling it an equation because I'm not using the equal sign to find anything on this side, although I could. Then this would be an equation. But we're just using small little chunks today of expressions, and we're going to compare them using visual models. So for example, I might use for this one 3 times 4 plus 2, I might say, okay, this square represents 3, and I have 4 of them. Okay, 3, 3, 3. And then I have a 2 extra on the end, right? So this would be 3 times 1, 2, 3, 4, plus 2. All right? So we're going to use a lot of tape diagrams today for our visual models. Let's go to the Learn book, Lesson 3, problem set, name on your paper. Draw a model, and we're going to be using tape diagrams today for our model. I suppose we could use a different kind of model, but that's what I'm going to use today. And then write the numerical expressions. So they've given us these expressions in words. When you see the word sum, that always means adding. Okay, so the sum of 8 and 7, so 8 plus 7, and then we're going to double it. So double it means times 2, right? So I'm going to take that 8 plus 7, and I'm going to multiply it times 2. All right? So if I do that as there's my expression. If I do that as a tape diagram, my little square here, it's going to represent 8 plus 7, and then I'm going to double it. Okay? And this would also be 8 plus 7, right? Okay, you don't need to solve. We're not solving today. If you want to for fun, this would equal 30, okay? But we're not solving today. 4 times the sum of 14 and 26. So 4 times means multiply. So multiply times 4. The sum means adding, of 14 and 26. So 4 times the sum of 14 and means, all right, addition, we already know that, sum and they go together, 26, okay? And how am I going to represent that in a tape diagram? Okay, so I've got this 14 plus 6, right here, 26, sorry. And now I'm going to multiply that times 4. So I'm going to redraw the same square 4 times. 1, 2, 3, 4. Okay? All right, next one. This isn't so hard, right? You just have to read carefully. That's the hardest part. 3 times the difference. What does difference mean? It means subtracting 37 and 5/10 and 24 and 5/10. Okay, so let's see the difference between. So that means we're going to go 3 times 37 and 5/10. Difference means subtract, minus 24 and 5/10. Okay. Now I can do the same thing. My little square is going to be the stuff in the parentheses. 37 and 5/10 minus 24 and 5/10. And then I'm going to recreate that same square 3 times. Okay, 1, 2, 3. Great. The sum of 3 16s and 2 9s. Okay, so if I have 3 16s, that means 3 times 16. And if I have 2 9s, that means 2 times 9. Okay, 3 16s and 2 9s. That means that I'm going to add those together. The sum means adding. So now I've got 3 times 16 plus 2 times 9. Okay, what I could do here is I'm going to draw 3 squares that represent 16. Right? 1, 2, 3 16s plus, there's a 9, and there's a 9. Okay, so 2 times 9 and 3 times 16, and then add them all up together. There's my tape diagram. The difference between 4 25s, when I see those two numbers right next to each other, that means multiply. 4 25s and 3 25s, so that would be 3 25s. And it's the difference between, so that means subtract. So I've got my 4 25s on this side. Oops. 4 25s here, minus 3 25s here. And that's gonna, that's my, I'm not calling these equations expression. Okay, that's my expression. So what I'm going to do is I'm actually going to draw 2 tape diagrams. This is 25, 25, 25, 25. And I'm going to subtract from that 3 sections of 25. And my answer is going to be whatever is left over, right? Good. All right, triple. Triple means times 3. Triple. Triple fudge sundae. 3 times the fudge. Triple the sum means adding, of 33 and 27. So 3 times 33 plus 27. Now I'm going to represent that in a model, so I'm going to take what's inside that parentheses and I'm just going to call that 33 plus 27. And then I'm going to triple it. Okay, so then this would be 33 plus 27, and this would be 33 plus 27. Okay, and if you wanted to go back and solve all of those problems, you sure can. We're not solving this right now. We're just changing these from words into expressions. Number 2, now we're going to write the expressions in words. So we're flipping it around. So we've got 12, right? 12 times, and then this is in parentheses. So we're going to call that the sum of, because we're adding, the sum of 5 and 25. Oops. Great. And the value of the expression means the answer, the value. So let's go ahead and solve. 5 plus 25 is 30. And 30 times 12 is what? Well, we can simplify this, and we can call this 3 times 10. Then we can just say 12 times 3 times 10, which would be 36 times 10, which would be 360. Right? Do you remember that from yesterday's assignment? Okay, so here we've got the difference because of subtraction, between 62 and 12 times 11, period. All right. And let's solve that. 62 minus 12 is 50. You should be able to do that in your head. And 50 times 11 is, well, remember how we were multiplying those yesterday? 5 and 10. So 5 times 11 would be 55. Times 10 would be 550. Good. All right. Now here we've got the sum of 45. I keep trying to cut corners by writing the numbers, huh? 45. If you don't know how to write the numbers, you need to practice that. And 55 times 23. Okay, so let's add that together. 45 plus 55 is 100. I can just see that in my head. I hope you can. And 100 times 23, well, 1 times 23 would be 23. And then we're going to add those 2 zeros back on there. So our answer is 2,300. Last one for number 2. Okay, so we could call that 30 times 2, or we could just say 30. No, let's go with the sum first. The sum of 30 doubled, right? Doubled means times 2. And 8, which is also times 2. Doubled. Okay. And 30 times 2 would be 60. And 8 times 2 is 16. So let's see. 16 times 6 would be 36. 36, 7, 8, 9. And then put the 0 back on. 960. Number 3, compare the two expressions using greater than, less than, or equal to. In the space beneath each pair of expressions, explain how you can compare without calculating. Draw a model if it helps you. Okay, well, let's draw a model. So I've got, well, I don't want to draw a model for that big number. This side is 20 plus 5, and that side's 20 plus 5. So those are equal. But this one is multiplied by 24, and this one is multiplied by 12. Well, which is the bigger number there? 24, right? Okay, so 24 times the parentheses is more than 12 times the parentheses. Do I need to find the answer to know that? No, I just look at that 24 and that 12, and I know that the 24 is bigger because this 20 plus 5 and this 20 plus 5 are the same. Okay. 18 times 27 and 20 27s minus 127, all right? So here we've got 18 27s, and here I have 20 27s, but I'm subtracting 1, so I really only have 19 27s. But that 19 right here is still bigger than the 18, so this one is bigger, okay? And 19 times 9, or 3 times 19 times 3. Okay, well, 3 times 3 is 9, right? So I could just multiply that times that, and multiply that. And then I've got 19 times 9 on this side and 9 times 19 on that side, so they're actually equal. But read those carefully. Tripled means times 3, and 3 19s would be 3 times 19. But 3 times 3 is 9, so 9 times 19 and 19 times 9 are the same. And I don't have to solve those expressions to know which one is greater than, which one is less than, and which one is equal to. Number 4, Mr. Hun wrote the sum of 7 fifteenths and 38 fifteenths on the board. Draw a model and write the correct expression. Okay. Well, see, I was doing it as I was reading it. I probably should have waited for the directions. Let's read all the directions before we start the problem, huh? I have that habit too. You guys gave me that habit. Wrote the sum, which means adding, of 7 fifteenths and 38 fifteenths on the board. Draw a model and write the correct expression. So there it is, 7 fifteenths and 38 fifteenths. The sum is adding them, and we're going to draw a model. Let's see. I'm going to split this into 15, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we're going to say each of those is 7. So this is 7 times 15. And then I'm going to add on here another 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oops, that got a little out of hand, didn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And each of these represents 38. Okay, so there's my expression. Number 2. 2 students wrote the following numerical expressions. Angeline wrote 7 plus 15 times 38 plus 15. And Mei Ling wrote 15 times 7 plus 38. Are the students' expressions equivalent to your answer from problem number 4? Okay, so let's find our answer from problem number 4. What is 15 times 7? Okay, that's 35. Carry the 3, 7, 8, 9, 10. So this side is 105. And then 38 times 15 is, that's 40, carry the 4, 15, 16, 17, 18, 19, and the 1, and then drop a 0, and 8, and 3, 0, 16, 17, carry the 1 is 5, so this side is 570, and add this together, and I get 675. Okay, so I'm going to erase my work here, but I like it when you show your work. So if you can leave your work on your homework, that would be great. Okay, I'm going to clean it up so that you don't get confused by it, but I would really like to see it on your work. So Angeline wrote 15 plus 7, right? Which would be 15 plus 7 is 22, and 38 plus 15, which would be 3, carry the 1 would be 53. All right. And if we solve 22 times 53, 2 times 3 is 6, 2 times 5 is 10, drop a 0, 2 times 3 is 6, 2 times 5 is 10, 6, 6, 1, 1. Okay, well that one was way bigger than ours. Okay, again, I'm erasing my work, but I'd like to see yours. And over here, I've got 15 times 7 plus 38. So 7 plus 38 is 45. And 45 times 15 is 25. It's 20, 22, 0, 5, 4. And we have 5, 7, 6. And that one equals 675, which is what we found, was our answer, right? Again, I'm erasing my work, but I like to see yours. So, are the students' expressions equivalent to your answer in problem number 4? Angeline got a different answer. Our answer was the same as Mei Ling. Okay. So, what did Angeline do wrong? She saw the sum of 7 15s, and instead of saying 7 times 15, she thought that that meant 7 plus 15. Do you see what she did wrong? And then here, she didn't realize that 38 times 15, she thought it was 38 plus 15. And then she didn't think it was the sum, she thought it was multiplied. So she had, where we did the multiplication, addition, and the multiplication, she had addition, multiplication, and addition. Do you see what she did wrong there? Now, this is interesting what Mei Ling did. Mei Ling got the same answer as us, but she put the 15 on the outside, right? She moved these 15s outside, and then she decided, you know what, I'm just going to multiply everything times 15, and I'm just going to add these two, right? So she moved the 15 over here, and then the sum of 7 and 38, right? Because really what we have is the sum of 7 and 38 15s. So Mei Ling just wrote it a little differently, but she got the same answer that we did. She just wrote it differently, which is so cool about math, is you can move those numbers around and you can still get the same answer as long as you don't change the multiplications and additions and subtractions and division signs, right? So, number 6. A box contains 24 oranges. Mr. Lee ordered 8 boxes for his store and 12 boxes for his restaurant. Write an expression to show how to find the total number of oranges ordered. Okay, so a box has 24, so one box equals 24 oranges. So if he ordered 8 boxes, that's 8 times 24 would tell us how many oranges for the store. And 12 boxes, which would be 12 times 24. Ooh, I'm sorry, I wrote 25 there. Here, write an expression to show how to find the total number of oranges ordered. So the store got 8 boxes of 24 each, and the restaurant got 12 boxes of 24 each. So our expression is 8 times 24 plus 12 times 24. Next week, Mr. Lee will double the number of boxes he orders. Write a new expression to represent the number of oranges in next week's order. So we already know what this week's order was, okay? There it is. And now he wants to double it, and he wants to double the whole thing. So what we're going to do is we're going to put brackets around the whole thing. Okay? And then we're just going to multiply by 2. Evaluate your expression from part B to find the total number of oranges ordered in both weeks. So we're going to do week 1 first. And that is 8 times 24 plus 12 times 24. So 8 times 24. Okay, let's see. 24 times 8 is 32. Carry the 3. 16, 17, 18, 19. 92. No, is that right? Nope, not right. Sorry. 8 times 4 is 32. Carry the 3. 8 times 2 is 16. Plus 3 is 17, 18, 19. There we go. That's way better. And 12 times 24. 2 times 4 is 8. 2 times 2 is 4. Drop the 0. 1 times 4 is 4. 1 times 2 is 2. And we've got 8, 8, 2. Okay, 288. And if I add those together, 188 here, I have 19 is 18, carry 1 is 380. Okay, so I'm actually going to erase my work a bit there. And equals 380 is my answer. Let me just see if that makes sense. Yes. Yeah, okay. And for week 2, guess what? I already know what this whole thing comes out to because I just did all the work. And so I can just figure out that all of that equals 380, all of this, from there to there. I'm going to multiply times 2. So that's going to give me 0, 16, carry the 1, 6, 7, 60. Okay? So all right. Week 1 and week 2. And if we want to find the total number of oranges ordered in both weeks, we're going to add those together, aren't we? So 380 plus 760 is 1,140 oranges. Okay, the total number of oranges ordered in both weeks. Very good. Okay, I hope that you're getting this. If you don't know how to write numbers in words, practice that, please. Great job. Have a good day.